Hello once again, our most valued student. My name is Confident and welcome to the continuation of the revision of this paper, Engineering Science N2, which was written in August 2023 or August 2023, and already we've looked at some questions. We looked at the first question, which is dynamics. So if you haven't gotten hold of that, check our channel. So now we are looking at what? Statistics. And then here, let's look at 2.1 here. It says, name two methods that can be used to solve parallelogram of forces. So there are two methods you can use when you're solving it. It's analytical methods where you are calculating. Analytical. Analytical method. When you're using analytical, so what you do is you are calculating, and then sometimes if you want to use the second method without calculating, what can you use? Graphical method. You can find the resultant funds by graphical methods. So there is the analytical method and the graphical method. These are the two methods that you can use when you're solving the parallelogram forces. And then the next one, 2.2, says an unknown force. Okay, it is unknown, so let's call it F, right? Is inclined at what? At 25 degrees to the horizontal. So let's sketch that already. The force is unknown, so this is my horizontal, like this, and this force is unknown like that. And then we're gonna call it F, and they are telling me the angle of inclination here is what? Is 25 degrees. Are you with me? That's it. And then they say the horizontal component, they are adding the horizontal component of the unknown force is 950. So where is the horizontal component? This is the horizontal component there. That is your F. I can call it F horizontal if you want. Alright, but if you check the formulas, go to your formulas. I'm not going to do that because these formulas, but let me just do it for you. Let's go to the formulas at the back. If you check the formulas here, there is the horizontal component, which is here. That's what you are using when you talk about vertical and horizontal component. So FC here is your horizontal component. FC is equal to W cos theta. Okay, so if I come back to this, we are now not going to call it F horizontal. We are going to call it what? FC. And you saw the formula. It says what? FC is equal to W, which is the weight, cos theta, and that's the angle. Are you with me? Okay, now we know what is our FC. They told us is 950 newtons. This FC. So you come here and say 950 newtons is equal to W, but now we're not gonna use W now. W becomes our F. This is the unknown force. F cos 25. Are you seeing that? Because this then is the W whenever you're doing that. And then how do you do it? To get rid of that cos 25, because it's multiplying, you divide by cos 25 on both sides. Alright, and then that's it. Then you find your F. So that is your force. When they call it the unknown force, F becomes what? Then definitely you use your calculator there to say 950 divided by cos 25. Now be careful that your calculator is in degrees. It's 1048.21. Make sure your calculator is in degrees. If it's in radians, it is going to give a false answer. Okay, or gradients, so it must be D. So it's 1048,209. I didn't check the rounding off. Let's write in 3 decimal places. 1048,209. So that is the answer we're gonna have to say 1048,209 newtons. Okay, but let's quickly check the rounding off. It's very important here. If ever they gave us any rounding off, yes, they say 4.4.4, the answer should be rounded off to 3 decimal places. These are very important things. Okay, So that's why even the whole of actually 4, I would encourage you to read it, because that's where you get your full marks here. You see how you get your full marks. So 3 decimal places, which is what we did already. So this is the final answer. All right, let's move on to look at question, yes, question 2.3. Question 2.3 says a horizontal beam resting on 2 supports L and R, that is obvious, is shown below. I think this was simplified than any other question that they usually bring. So you've got the 80 newtons that is pushing down, you've got the 40 newtons and the 35 newtons, and then you can see the supports. Are you with me? And then the question is, okay, obviously they'll say determine the reactions of both supports. That's the question there. It says determine the reactions of both supports by taking moments about each support and then ignore the weight of the beam. But now, before that, let's identify a few things. The distance that I think we don't know is that one. Let's look at this distance, because it's very important that we get that distance here, because the distance there is 4,5. So what is the distance here? It's more like we are saying, if I divide, it's more like here. Okay, it's more like here. All right, there it is. Here I've got what? I've got 1 meters. All right, and then again I come here. I've got what? Between here and here. If I can have, okay, let me have my line like this. See this? This becomes what? 2 meters. So the question is, what is this distance now that is left? It's not difficult, guys. Look at it carefully. What is this distance? If the total is 4,5, if I say 4,5 minus 2 minus 1, do you see that I get 1,5? So this distance is what? Is 1,5, this one. So that if I say 1 plus 2 plus 1,5, it will be 4,5. So don't forget, you have 1,5 meters. Are you with me? So that is the main thing there that I wanted to bring to you, to remember that. Okay, so that is that. Let me not take it down. How about I do this? I do this and lower it a little bit like this. Okay, let's lower it a little bit like that, just to remind ourselves how we got it. Okay, I think it's fine like this. Okay, now let's come back to the working here. We are going to take moments about L. Let's start there. But now there is a formula. Let's go to the formulas. The formula that you use is this is the formula that you use here. You see, to say that the first one is sum of clockwise moments is equal to the sum of anti-clockwise moments. So this is the formula that you use. Okay, so you just write that formula there to say sum, let me use this to say sum of, you do this, see, meaning clockwise moments is equal to sum of, and you do this, meaning anti-clockwise moments. You see the arrow will be like this, and in the clock this is anti-clockwise, and this one it will be like, is turning like this. So in a way, what you are doing here, you are saying this side is clockwise. That's the formula, clockwise moments. You can write it like this, that will give you an answer, is equal to anti-clockwise moments. But you must say sum. You must not forget the word sum, because there is this sign there. So you must say sum of clockwise moments is equal to sum of anti-clockwise moments. Then from there we come to our beam, because that's where most of the thing confuses students. Remember, we are taking moments about L. Okay, I didn't write that. Let me write that. Take moments about L. Take moments about L. Now I just want to make this clear, if ever I can draw this. So let me just do quickly that. We want to take moments about L. So what you have, if this was the beam here, use this one. If this was the beam, and then where is L? L is just somewhere here. We're gonna take moments about L. L is somewhere there. And then you know R is somewhere there. So if I'm taking moments about L, so what I'm trying to say to you is forget about L. Okay, we're going to do that. But now what were the other forces? I think it will be making sense. 80, 40 and 35. Let me bring them in. You've got the other forces, which is here at the end. It's 80, and then the other one, it's there, somewhere there, which was 40. So it's not going to be to scale now, which is 35. You got these forces, which is 80 newtons, which is 40, which is 35. So if I say take moments about L, what I'm trying to say, I'm saying ignore that L existed. Ignore this. Ignore that L existed. And what are you saying when L is not there? You are taking moments about L. But now let me bring this back. If L, we do this. I don't know how I can put it. Let me put it like this. If L is my point, let me put it like that. Put L away, but we know that L is there. Let's put L away. And then for now, since L is away, what we are saying is which moments are turning. Remember, we've got I think I need to bring it back. Sorry about that. Okay, but fine. But ignore in your mind. Just ignore this one. Just ignore this one. All right. And then you ask yourself which forces are going to be pushing clockwise or anti-clockwise. Follow the part of the arrow. For example, let's look at this force. This force about L. You see that about L, it is going to be doing this because it's pushing down about here. You see that? So what force is this? This force is anti-clockwise. This one is anti about L. You see? And then let's go to the next one. Look at this one about L. Do you see what it does? Even this one, do you see what it does? What is it doing? It is doing clockwise. Are you seeing that? So these two are clockwise. Even this one, we say it is what? It's clockwise. But now let's look at this one about L. This will go like this. What is it doing? Anti. Do you see that? This is anti clock. I'm just going to use that. So from here, you can now use the formula which says sum of clockwise is the sum of anti-clockwise. So what do? You are going to say sum of clockwise. We are going to start now to say 40 times from L. They told us 40 times what? 40 times 1. You say that? Continue with the other clockwise. 35 times from L. Now what is the distance from 35 from L? Is 2 plus 1, which is 45 times 3. You see that I say? Is there any other clockwise? No. Is equal to, you see. Then anti-clockwise, there it is. It was 80 times what? 80 times 1. You see? Plus the other anti-clockwise was the support, which is what? R times, they gave us 4,5 between L and R. You see that? Which is 4,5. 4,5, it's R. Okay, let me do like this. It's actually R times 4,5. Guys, you see, that is the first one. And then we just simplify this using the calculator here to say, in a way, it's 40, which is 40 times 1 plus 35 times 3, and then take this to the other side. 80 times 1 is minus 80 is equal to R times 4,5. then you can have a calculator which will give you this, to say 40 plus 35 times 3 and then minus 80 equal to 65. But after that, I'm gonna divide by 4,5. Divided by 4,5. I'm dividing already, which is 14,44. So here I'm gonna, it was 65 was r times 4,5. I'll divide by 4,5, divide by 4,5, and then what was the answer? 14,44. 3 decimal places is equal to r. But don't forget, you are dealing with newtons. You see, that is the first thing. Then the next one, I just want to do it on the side here. Let me just do it just parallel here so that we don't do a lot. The other one, what does it say? It says we now have to take moments. You see, let me make this long. We are going to take moments about, like we did here, take moments about L, but this time we're going to say take moments. I know I'm taking time about R. This time we're taking moments about R. Alright, so you do the same thing. Sum of anti-clockwise moments is equal to sum of clockwise moments. It's always the formula, okay? And then you do the same thing here, but now I want you to come back here. So I'm gonna take this off because it was based on the previous. Let's take this off. Alright, now our focus has changed. We say take moments about what? We are now taking moments about R. This is R. We are here. This is our focus. And we ask ourselves, how are these forces acting? Now look at this. Remember your focus. This is your focus. Everything must be coming to here. So this is it. Look at this one. It's going this direction. Is it clockwise or anti-clockwise? Look at this one. About R is going this direction. Is it clockwise or clockwise? Look at this one also. About R is going this direction. Do you see that all three of them, they are anti-clockwise? Did you see that? So this one is anti, this one is anti, and this one is anti. Remember I said about R, but the only one that is opposing that, it is this one which will do like this about R, which is what? Which is clockwise. It's the support. You see that? So now when we start multiplying, all of them at the top, remember, they are anti-clockwise about what? About R. So we come back here and say the first one is 80 times what? It's 80 times the total distance. Look, how long is this beam? This beam is 4,5 plus 1. Don't forget that 1. So it's 5,5. So it's 80 by 5,5. So I'll do the same thing here to say it's 80 times 5,5 plus, we continue the next one, which is 40. 40, we say that was 1,5. So 2 plus 1,5 is what? 3,5. Remember, it's about R. So 40 times 3,5. So we have 40 times 3,5. That's all that you need to be careful. And then the other one is what? Is 35 times 1,5. Do you see that? So those are anti-clockwise. So it's 35 times 1,5. All these were anti-clockwise, equal to clockwise moments, which is what? Which is here. We said it's L, and they told us the distance between the supports is 4,5, which is L times 4,5. That one was not much there, which is L times 4,5. And then you simplify this, and then after simplifying, then we get the answer. So let's just simplify this. It's 80 times 5,5 plus 40 times 3,5 plus 35 times 1,5, which is what? Which is 632,5. So I've got 632,5 is equal to L times 4,5. Then what do you do? Like previously, you divide by 4,5. It will give us the support at L And then if I do that, I'm just going to say 632,5, am I right, divided by 4,5, and then I'm getting 140,55555, which is 140, by the way, you can round off with this calculator. Shift setup, and then you go to 6, fix to 3 decimal place, you say 3, then you press ST there. 140,556, 140,556 what? Newtons. And then these are the answers, the supports. But you can prove them. Proof. There is always proof that is good for you to check if you did your answer right. You can use this formula for the proof. This is the formula that you use for the proof, the top one. It says sum of upward forces is equal to sum of downward forces. So you can come here and say sum here of upward forces is equal to sum of downward forces. You get what I'm saying? Then you look at all the upward forces, and if you go to the diagram, those that are facing up is L and R. So which means we're going to add here L plus R is equal to all those that are coming down. Are you getting what I'm trying to do? So what is L plus R? We know that our L is this one, we got it, which is 140,556 plus the other one, which was our R, which is 14,444. You see this? 14,444 is equal to those that are facing down, 80 plus 40 plus 35. I get it, what's happening there, which is 80 plus 40 plus 35. If these are the same, it means you did well. But remember, this you are not showing us. They didn't expect you to show us, but this is what I'm trying to say. Use that just to check that you're correct. 556 plus 14,444 equal to, on the left hand side I get 155. So let me add the other one. 80 plus 40 plus 35 equal to 155. So look, 155 newtons equal to 155 newtons. Do you see that the left hand side is balancing the right hand side? So it means in this case your two answers that you have, they're definitely correct. See, that one is correct and this one is correct. Alright, so guys, we have come to the end of our lesson where we're looking at this question, and now let me just clarify a few things. I'm going to be looking to the next is question number 3, energy and momentum. You can see it's 7 marks, and then we go on further to look at work, power and efficiency, question number 4, which is 10 marks. We continue. The one that takes more marks is always mechanical drives and lifting machines. You know, it's 17 marks until the end of this paper. But look, I'm going to do a few for you. I'm going to do a few questions that I'm going to post on everyone, but the rest of the questions I'm going to make them available to premium members, and premium members are those who contribute every month to this channel. You know, so what they get to benefit is there are some videos that you don't see or that you are not able to watch. I think you have tried to click on those videos and then it says you are not a member. So those are the people who support this channel, and we really appreciate them so much, because they help in the success of this channel. So I will encourage you, become a part of our premium membership so that you can benefit on the other videos that are not able to be viewed by everyone. And you're also helping in the success of the same channel. You also help in bringing these free videos to everyone who can benefit, who is not able, you know, financially able to also what to pay for the for these premium members. It's not a lot. It's about from 55 rand, I think 80 rand or so. It's not a lot of money for a month, but you are able to view the full memo of this video, as well as other different memos that are already available of this channel. So I will encourage you, please, if you want to become a part of premium members, then do so, and you can go to the YouTube channel where it says join, and then you can become a premium member. you are helping in furthering this channel. Thank you once again if you are a premium member. Thank you once again if you are our subscriber. Remember to share this channel with others. We've come to the end of our lesson. Thank you.